Welcome to all. I am Professor Sandeep Aher, lecturer as Mechanical Engineering Department, Sandeep Polytechnic, Sandeep Foundation, Nasik. So friends, today we are going to discuss that advanced manufacturing process, in which chapter number 1, non-conventional machining methods, is allotted for the 10 marks as per the MSBT scheme. So as per the MSBT, outcome based learning, so students should know in the chapter, so that course outcomes maintain non-conventional machining process to produce complex and hard machining components. So as per the syllabus, we have covered in previous lecture fundamental of non-conventional methods. Now we are going to see next methods of non-conventional processes. So just review this. We have covered in previous lecture need of the conventional methods, importance of the conventional methods, then classification, then after that difference between conventional and non-conventional methods. Now we are going to see the second subtopics as the directly process. In the first chapter we have covered total 8 non-traditional machining processes are there. So as per the energy level, that mechanical, thermal, electrochemical. So we are going to see first abrasive jet machining processes. So now first process, abrasive jet machining processes. It is the advanced manufacturing process. Let me first tell you what is the manufacturing process. It is very simple. Raw material is converted into finished product. That word is very simple. Raw material is converted into finished product. But just we have observed the how to convert that raw material into finished products. That raw material undergoes the n number of machines. Then at the last we have produced at the final design of the product, that is called as finished products. So every manufacturing processes are divided into three categories: positive type of manufacturing process, negative type of manufacturing process, and zero type of manufacturing process. So I would like to say, what is the exact zero manufacturing processes? Zero manufacturing processes in which there is no wastage in the process. This is called as zero manufacturing process. For example, casting. Whatever raw material, then this raw material can molten into mold cavity, then it solidify, then that part is known as a casting. So that input to output there is zero wastage, that's why it is called as zero manufacturing. Then positive type of manufacturing process. So positive manufacturing process in which some addition of materials are added under the process, such process called as positive type of manufacturing process. For example, welding. When two plates are welded with the melting state, so some extra filler rod is added that material. So that's why it is called as positive type of manufacturing process. And this is last, this is the negative type of manufacturing processes. So I have specially said that all these advanced manufacturing processes or machining processes under these negative type of manufacturing processes. Whatever, this is the first abrasive jet machining processes. It is also negative type of manufacturing processes because in this process material can remove from raw material to finished product. So that's why this is called as a negative type of manufacturing processes. So start the first process, abrasive jet machining processes. So it is shortly says AJM, and we have already observe in the classification of non-traditional machining processes, it under the mechanical energy level. So first, what is meant by abrasive? Abrasive, it is a one of the crystalline material like aluminum, silicon, then jet. Jet means it is a device is used to high jet of velocity of flow, and machining, it is the process means by using abrasive material with the help of jet, that process called as abrasive jet machining processes. Just see the introduction. So abrasive jet machining is a non-traditional machining process which is mostly used in machining of hardened metals. In previous lecture, I already said that in non-traditional machining processes, there is no contact between cutting tool and workpiece. So that's why it is called as non-traditional machining processes. And in this process, tool is always soft than the raw material. And in conventional, tool is always harder than the raw material. Now, in this machining process, a focus stream of abrasive particles are forced to impinge on the workpiece at high velocity. Because in this process, there is no contact between cutting tool and workpiece. So how to remove that material? So in non-traditional machining processes, material can remove by erosion process, spark process, or melting or vaporization. Now, these high velocity abrasive particles remove metal by brittle fracture or erosion from the workpiece. The abrasive particles are typically of 0.025 mm diameter, and these abrasive particles are like spherical shape and air discharge at a pressure of several atmosphere. Then I will suggest you, as per the exam point of view, this is the theoretical question. So these questions try to write first principle, then figure, then construction, then working, then process parameter, then advantages, then disadvantages, and at the last application. So let us try to discuss first process, that is abrasive jet machining processes. Its principle, it is only single line. This machining process works on the base of principle of abrasive erosion, or it is also says this is mechanical under machining process works on the basis of abrasive erosion. Now observe in the simple block diagram, it is the workpiece. Now this is the cutting tool position. Okay, now this is the nozzle. Now nozzle, air and abrasive particles streamline velocity is passing through the in between, and this high jet velocity of abrasive strike on the workpiece, the concentrated point, and thus abrasive erosion is takes place and thus remove the material. It's simple principle. Now setup of the abrasive jet machining processes. Now every book, some of the equipments are different, but as per our curriculum, it's very simple figure like this. First, gas supply is there. Now gas supply, then after that there is a wall is there, then filter, then again wall, then pressure regulator, then vibrator is provided here, then powder supply and mixture, then food control wall is there, then one of the hose that is connected to the nozzle, and here workpiece, and then hood is provided, and then it is again provided to the system as a exhaust. Now I just explain the brief one by one. So gas supply, in which gas supply, that is a cylinder store the argon gas, nitrogen gas, or compressed air may be there. Now this air, there is a wall is provided. Whenever it is required, then it is open, otherwise normally it is switch off. Then filters are required. Why that filters are required? To remove the impurities and dust or whatever impurities form in the gas. Then it is passed through these. Again provide the air wall is there for the safety purpose. Then it is one pressure regulated to regulate the pressure as per the requirement of this process to regulate the pressure. Now this line is connected to the here powder supply and mixture. Here is the abrasive materials. So which abrasive material? Aluminum oxide, then silicon carbide. These materials it mix in the mixture or container, and now this gas get mixed again this chamber. Here abrasive particles and gas get mixed each other, then it form as a high velocity of vibration. That's why here vibrator is provided to mix properly or uniformly that gas plus abrasive. Then it is passed through the hose line. This hose line is connected to the at the nozzle. So it is again one control system is provided, that is a foot control valve, means again regulate the flow of velocity of the abrasive particles. Now here nozzle is provided. So that what is the function of nozzle? Nozzle is the device that pressure energy is converted into kinetic energy or high jet of velocity. So these abrasive mixed particles is passing through this nozzle. So I'd like to say that nozzle, that material should be different because there is a high jet of abrasive materials, so it does not affect on the nozzle material. So that's why nozzle should be tungsten material, or it may be sapphire nozzle. It's a special material to sustain the all properties whatever affecting on the nozzle. Now this high jet of velocity of the abrasive materials strike on the workpiece, and then here erosion is takes place, and thus to remove the material by means of these abrasive materials. So when you observe that in grinding machines, when grinding operation is takes place, so certain stars are happening there. So for human safety purpose, that hood is provided, and that hood, when this nozzle and workpiece, when operation is takes place, so it forms some heat, and that's why exhaust is provided to remove that fumes like exhaust. Now this is simple. Let us see one by one. This is a figure to draw basic setup. So gas supply, then it required regulators, then chamber need to the mix gas plus abrasive, then foot operated control valve is required hose, means there is a one of the pipe, then hand holder for the take the position of the nozzle, then workpiece, hood and exhaust. That's the next. Now construction. When your theoretical question is that construction write in a single line sentences, but first process, that's why I have explained one by one in briefly. So construction, it consists gas propulsion system. Gas propulsion system. So in which the main purpose of gas propulsion system is to provide clean and dry high velocity air or gas for the machining. Already said that which gas is used in the cylinder, that is carbon dioxide may be there, nitrogen may be there, air may be there, or argon may be there, or the gas are used for the cylinder or air purpose. Compressors are required, and as per the pneumatic system, compressors wherever, so air filter and dryers are compulsory or essential parts. The gas used in this system should be easily available. First, gas is compressed into a compressor, then compressed gas is sent to filter and dryer where all dust and unwanted particles along with moisture is removed from it. So that's why filter function to remove the impurities, also moisture, and clean air is then sent to mixing chamber. Already seen that in the construction. Then second, abrasive feeder. Abrasive, it is one of the material. So feeding system is used to provide abrasive particles in mixing chamber. So it is fed through sieve which vibrates at the frequency 50 to 60 Hz, and mixing ratio is controlled by the vibration of the sieves and its amplitude. That's why vibrator is provided. Now, what are the abrasive materials? So at the exam, just mention the material. Don't write these all these points. Okay. So first, these are the main particles which take part in machining processes. Because this is the ingredient of this process. These particles should have high metal removal rate and accuracy. So that material rate should be high. It is simply says MRR, material removal rate. And it also maintain the accuracy. God already said in the principle that material size is 0.025 mm. So that abrasive material should be like aluminum oxide, silicon carbide, or boron carbide. So you should remember that materials are very important. Sometimes 2 marks question may be there. So what are the abrasive material? So students should know this material: aluminum oxide, silicon carbide, boron carbide. And then selection of the abrasive particles is depend upon its material of workpiece, speed of machining, and machining environment. Now, cutting nozzle. To direct the abrasive particle on workpiece, cutting nozzles are used for high jet velocity purpose. They are usually made of tungsten carbide, or again I said one of the best material, that is Saparia. They are available in both circular and square cross section. Its life is usually low, about 30 hours for tungsten carbide. Now next is machining chamber. It is a fully closed airtight chambers in which it is the mixture of abrasive material plus gas, and it is equipped with vacuum dust collector which collect use abrasive particles and remove material from the chamber. Then working process. It's very simple. I already learned that. So let's see one by one. Try to write first sentence. It is the negative type of manufacturing processes in which it under the mechanical based non-traditional machining processes with abrasive erosion is to remove the material. So let us see that construction also here, because it's very simple to understanding base. The basic concept of abrasive jet machining is abrasive erosion or metal cutting by high velocity of abrasive particles. So first gas or air is compressed into the cylinder. Then this compressed gas is passed through the filter is to remove the impurities or some particles or also absorb the moisture. Then this gas is passed through this wall because wall is there for safety purpose to control this process. Now, this compressed gas sent to filtration and where dust and other suspended particle removed from it. Then clean gas sent to dryer which absorb the moisture and some dust particles also. Then the clean and dry gas is sent to mixing chamber where abrasive feeder feed abrasive particle in it. The abrasive particles is about 50 micron meter grid size. Already said that micron abrasive material size is very less in form of micron. This high pressurized abrasive carried gas sent to the nozzle where it is pressure energy is converted into kinetic energy, that is the function of nozzle, and that velocity should be near about 200 meter per second. Then as we have observed in welding processes that raw material and this gun having some gap is there, otherwise that material get directly stick to this gun. So that purpose standoff distance is required, means gap between workpiece and nozzle, that is maximum 2 mm. So whenever that, just consider it, when that gap is maximum, so what happen? So that whatever removal of material that should be on affect on the workpiece, that cutting size maybe gets taper or like different shapes. So that's why standard distance are there. That's why standoff distance, or it is called shortly SOD. These high velocity abrasive particles impinge on the workpiece. Impinge means strike on the workpiece. And these abrasive particles remove the material in form of micro cutting action, like in form of powder or some melting or evaporation. But in brittle material, it form in the powder form. Now, sometimes question may be there to write the process parameter of abrasive jet machining. So for successful utilization of abrasive jet process, it is necessary to analyze the data. First one is material removal rate, that is MRR. It depends on the high jet of velocity, again standoff distance, means gap between workpiece and nozzle. Then geometry of the workpiece. Cutting action maybe depend on the geometry of the workpiece or its strength or depends on the material. Then surface finish of the workpiece. So when we require more surface finish, so you have to maintain the standard parameters. Otherwise, that parameters gets increased, so we get poor surface finish. Now, wear rate of nozzle. In wear rate of the nozzle, because in nozzle pressure energy is converted into high jet of kinetic energy. That purpose nozzle should be strong material, because in this hose that material is passing as gas plus abrasive. So that's why nozzle material should be like tungsten or sapphire nozzle. So that's why your wear rate should be low. So these are the process parameter of the abrasive jet machining processes. Now every process has some advantages, some disadvantages, and it is compulsory part to the application. Now, we have to say some advantages. And that advantages for the non-traditional machining processes, some common advantages and disadvantages and application to apply all the processes. So first, high surface finish. So non-traditional machining processes are used high surface finish because it fulfills the requirement of today's age technology. That purpose we have used non-traditional machining processes, and there is comparatively advantage of the conventional machining processes, means you get very close dimension. Then again one of the operation, its operation is burr free, does not form any burr or sharp edge on the workpiece after operation, because you observe in lathe machine so that material gets some scrap or burrs are formed. Second, it can machine heat sensitive material. Can machine heat sensitive material, means that material having properties should be sustain the heat because high abrasive jet is strike on the material, so that's why material should be strong. And it is free from vibration, for that process is very precise, so that's why this is free from vibration. Then initialization cost is low compared to other non-traditional processes because this is a mechanical base, so there is no need to extra electricity or laser or plasma like processes, so that's why their initial cost is less as compared to other non-traditional machining process. Then thinner section can be machined easily. It is depends on the like process parameter again. Then again advantage, it is used for to form any complex shape. This is also advantages. And there is no contact between cutting tool and workpiece. Now we'll see the disadvantages. Every process having some disadvantages. So as per the conventional process, for that purpose, low metal removal rate, because in conventional that material removal in form of chips, but here that material is directly burr free or melting or vaporization. So that's why no material, low metal removal rate, and it is common disadvantage to all the processes. Then abrasive particles can be embedded into workpiece mostly in a soft metal. So in advantages we have already mentioned that material should be required strong. So otherwise that abrasive material gets strike on the workpiece and that material gets maybe soft, so should be melt like. So that's why workpiece mostly in soft metal, it's difficult. So nozzle life is limited, so it need to frequently replacement because abrasive materials are continuously passing through these nozzle, so that's why nozzle life should be limited. So that's why we have already said that nozzle material should be like tungsten or sapphire nozzle. Then abrasive particles cannot be reused in these processes. After operation, that abrasive material gets some like defective, not at actual quality of that abrasive material, so that's why not use or reuse that abrasive for the another processes. So this is a disadvantage. And then last, it cannot use for machine soft and ductile material because abrasive material gets strike on the workpiece, so there may be chances for the melting of these workpiece, so that's why it is not used for the soft material or ductile material. Then last, application of abrasive jet machining processes. So few examples are there. You have to write any two example of the abrasive jet machining. First, this is used for abrading or frosting for the glass articles. When you are visiting to the glass shops, so there is a process of the removing of the burr on the glass or some addition of materials. So that purpose these processes are there, abrading and frosting for glass articles. Means you get more finish. Then fine drilling and micro welding. So when need to these required to produce the small drill hole, so that abrasive jet machining process is also used. Then micro welding means when small thin plates are there, for that welding purpose abrasive jet machining methods is also used. Then machining of semiconductors. Already known that word is related to the electrical. So machining of the semiconductors are required abrasive jet machining. Then cleaning and cutting operation on materials like germanium, silicon, quartz and mica. That material cleaning base that abrasive jet machining process is used. Then machining of brittle material like glass, ceramics and refractories etc. I already said that in disadvantage this process is not used for the soft material and dark material and the ductile materials. So friends, I hope you should understand these abrasive jet machining processes.